videos ago, we said RAG lives inside the retrieval block of an AI system, and we'd open that block in its own video. This is that video. Here's the core idea in one sentence. A good RAG system doesn't make the model smarter, it makes sure the model never has to guess. The model didn't suddenly know your contract. It knew where to look. A language model only knows what it learned in training. It has never seen your contracts, your tickets, your internal wiki. Ask it a question about your data, and it does one of two bad things. It says, "I don't know," or worse, it makes something up that sounds right. RAG, retrieval-augmented generation, fixes this by fetching the relevant facts first, then asking the model to answer using only those facts. Why should a leader care about a retrieval pipeline? Because RAG is how AI touches your proprietary knowledge without retraining a model, which is expensive, slow, and goes stale the moment a document changes. Update the document, and a RAG system answers correctly the same day. That's the business case. Fresh, sourced answers over private data with no retraining bill. RAG is two halves bolted together. Retrieval. Find the right pieces of text for this question. Generation. Write an answer grounded in those pieces. Here's the part most people miss. Answer quality is decided in the first half. By the time the model generates, the outcome is mostly locked in. Garbage retrieval, garbage answer, no matter how good the model is. So here's the full pipeline. It splits into two timelines. First, offline, done ahead of time. You take your documents, chunk them into passages, turn each chunk into an embedding, a numeric fingerprint of its meaning, and store those in a vector database. Then online, when a question arrives. You embed the question, search for the closest chunks, re-rank them to put the best ones on top, assemble them into the prompt, and the model generates a grounded answer with a citation. 8 stages. Most teams build 2 of them, embed and search, and wonder why it's mediocre. Let's zoom into the stage that quietly decides everything. Chunking. Chunk too big, and a passage covers 5 topics. Retrieval gets fuzzy, and the model drowns in noise. Chunk too small, and you slice a sentence in half and lose the meaning. Good chunking respects structure. Sections, clauses, headings, and often overlap slightly, so context isn't cut at the seams. Boring? Yes. It's also where most RAG quality is won or lost. Next, how search actually finds the right chunk. An embedding turns text into a list of numbers that captures meaning. Chunks about similar ideas land near each other in that space. So when a question comes in, we embed it too and grab its nearest neighbors. The power here is matching on meaning, not keywords. Time off for a new baby can find a clause titled parental leave, even with no shared words. More meaning search has a blind spot. Exact terms, product codes, clause numbers, names. Vector search can fuzz right past them. So serious systems go hybrid, combine keyword search with vector search to get both precision and meaning. Then a re-ranker takes the top candidates and rescores them against the question more carefully, pushing the genuinely best passage to the top. Retrieval gets you close. Re-ranking gets you right. Let's make it concrete with a fresh example. A contract assistant for a legal team. A lawyer asks, "What's the termination notice period in the Acme agreement?" Watch it move through the pipeline. The question is embedded. Hybrid search finds candidate clauses. Vector search catches termination phrased as end of agreement. Keyword search nails the exact party name, Acme. The re-ranker surfaces the precise termination clause. The model answers, 60 days written notice, and cites the clause and page. The lawyer verifies in 1 click instead of reading 40 pages. That citation is the whole point. RAG doesn't ask you to trust the model, it shows its source. Where does RAG go wrong? Almost always in retrieval, not generation. missed retrieval. The right passage exists, but search didn't find it, so the model answers from thin air. More chunks improve recall, but raise cost and latency. And stale data. If your index isn't refreshed, you're confidently citing last year's contract. When a RAG answer is wrong, your first question shouldn't be, is the model bad? It's, did the right chunk even make it into the prompt? One risk deserves its own moment, and it's the one that ends careers, not just demos. If retrieval can fetch any document, an intern can ask a question and get the CEO's compensation clause. Permissions must be enforced before retrieval, not after. Filter what a user is allowed to see before it ever reaches the model. RAG without access control isn't a search tool. It's a data leak engine with a friendly chat box. How do you know it works? RAG has two halves, so it needs two kinds of metric. For retrieval, context recall. Did the right passage actually get retrieved? For generation, groundedness. Is the answer supported by what was retrieved with no invention? Plus the practical ones. Answer correctness, latency, and cost per query. And here's the diagnostic trick. If groundedness is high, but answers are still wrong, your retrieval is failing, not your model. The two metrics tell you which half to fix. 5 takeaways. 1. RAG retrieves facts first, then generates, so the model never has to guess. 2. It's a pipeline. Chunk, embed, search, re-rank, assemble, generate, cite, not just a vector database. 3. Quality is decided in retrieval. Serious systems use hybrid search and a re-ranker. 4. Enforce permissions before retrieval and keep your index fresh. 5. Measure both halves. Context recall for retrieval, groundedness for generation. So, what data would you point a RAG system at first? Policies, contracts, support tickets, product docs, or a knowledge base? Tell me in the comments, and I'll design the retrieval pipeline for whichever one wins. Next up, we compare RAG to fine-tuning and AI agents, so you know which one your problem actually needs. Follow for practical AI system design.